All right, so percentiles is another way of measuring the position of a data point, and percentiles divide the data set into 100 equal groups. And we actually have worked with percentiles before. You probably ran into it when they talk about like your ACT score, you're in the 90th percentile or the 85th percentile or something like that. So let's go look at percentile rank and talk about what that means. So an example of a percentile rank would be of something like the 72 percentile. This means that a person that ranks in the 72 percentile means that that person is scored above 72% of the people that took the test. So like if you're in the 72 percentile and you take a test, there are 72% of the people scored below you on that test. So you scored above 72% of the people. 90th percentile would mean that you scored above 90% of the people. So the higher percentile means the more people you scored above in whatever it is that you're working on. The symbols for percentile, the first percentile is P1, the second percentile is P2. This means that you're at the 1 percentile, the 2 percentile, and so you got P3, P4, all the way up to P100, or actually you can't score above 100% of the people to take the test because you're a person in that test. So you can go up to the 99th percentile. You scored above 99% of the people that took the test. It's like a cumulative relative frequency. We did those, the ogives, a relative ogive, except it's written as percents instead of just decimal values. So what we want to do with this one is figure out how to find percentile ranks of data points and how to figure out the data point that's a particular percentile rank. So let's say we have a data set that measures the weights of boxes, big boxes. Okay, so we have these weights, 82, 78, 92, 86, 96, and 88. So these are all in pounds, let's say. Oops, I don't know why I dotted my L. So these are all in pounds. And so this represents weight. So one of the first things that you want to do is, if you're going to find percentile ranks of each of these values in the data set, which is what we're going to do, is we want to first rearrange the data set to be smallest to largest. So first thing to do is order your data from smallest to largest. So if we order our data from smallest to largest, let's see, 78 is the smallest, and then 82, and then 86, 88, 92, and 96. So now we have our data in from smallest to largest. And now the question that we want to answer is we want to find the percentile ranks of each value in the data set. So to do that, we have a formula. So if we want to find percentile rank, it's equal to the number of data points below whatever one we're looking at, the data point we're in, and then you have to add a half, okay? And then this is divided by the total number of data points and because we want this to be a percentile, we have to multiply it by 100%. So let's look at the percentile of 78. That's the first data point. So 78 is our first data point, and we want to find the percentile rank. Okay, so the first thing is how many data points lie below the number 78? Well, none. It's the first data point. So this percentile rank is going to be equal to 0 data points below plus 0.5 divided by, and how many data points do we have? 1, 2, 3, 4, 5, 6, divided by 6, and then we're going to multiply by 100%. So first we go 0.5 divided by 6, and then we're going to multiply that by 100, and we get 8.33%. Now, remember, percentiles go in integer values. So this is approximately the 8th percentile. Okay. So this is the 78 is approximately at the 8th percentile. So let me keep track of these numbers. Let's put it down here again. All right, so now let's look at 82. So we want to figure out the percentile rank of 82. So this percentile, I'm going to write it in this form, is equal to how many numbers lie below 82? Well, 1 does. So we have 1 plus 0.5 over 6, or 1.5 divided by 6. Oh, I always do this, guys. We're going to multiply this by 100% to make it a percentile. So this is 1.5 over 6 times 100%. And what do we get? So 1.5 divided by 6, we get the 25th percentile. So 25th percentile. Okay, now we're going to do it for 86. So the percentile rank of that, if we look at 86, there are 2 numbers below it. So we're going to go 2 plus 0.5 over 6 times 100%. So that's 2.5 over 6 times 100% equals 2.5 divided by 6 times 100 is 41.67. And so I'm going to round up because that's the closest percentile. So that's 42, the 42nd percentile. So on this one, this first one I rounded down because 3 rounds down. I'm going to go to the nearest integer. Okay, so now we do 88. The 88th percentile, there are 3 numbers below it. So we have 3.5 divided by 6 times 100%. And that's 58.33, so this is going to be the 58th percentile. And 92, there are 4 numbers now. divided by 6 times 100. That's the 75th percentile. And the last one, 96, there are 5 numbers below it. So I get 91.67, so it's 92nd percentile. Okay? So those are all the percentiles that way. So what about asking the question, which number would correspond to a particular percentile? So let's ask a different question. Same data set, so let me grab it again and bring it down. So same data set. I want to ask the question, let me get some of these marks. Okay, so what value would correspond to the 50th percentile? Okay. So again, to answer a question like this, you still have to have your data ordered from smallest to largest. Now, the formula in this is they let C be that position. So this tells me C is the position of the number that satisfies the percentile rank. Okay. And then we're going to use the number P. This is the percentile. And this is not written as a decimal, it's just the percentage. And N is the total number of values. And so the formula is the position of the percentile, the number that represents the percentile rank, is equal to N times P over 100. All right, so if we want the 50th percentile rank, this would say there are 1, 2, 3, 4, 5, 6 numbers. So N is 6, P is 50, and we want to divide by 100. And if we do that, we get 300 divided by 100, or 3. Now we got to be a little careful here, because it turns out if C is a decimal, you round up to the next whole number. So we'll do an example of that. If C is a whole number, you find the average between the C and the C plus 1 term. Find the average between C and C plus 1 term. Okay, so what's this mean? So let me grab our data set again and pull it down so we can look at it. Okay, so RC became 3. So if we look at it, here's the first number, here's the first number, the second number, the third number, the fourth number, the fifth number, and the sixth number in our data set. So 3 is right here, but because it's a whole number, what I have to do is take the third and fourth number and average those to find the value that will be the 50th percentile. So I've got to go 86 plus 88, that's the third number and the fourth number. That's our C and C plus 1 number. And then add them together and divide by 2. So that's going to be 86 plus 88, 174 divided by 2, and that's 87. So the 50th percentile number is 87. Okay, so let's ask, instead of doing the 50th percentile, we got a C value that was a whole number, and we had to use this second condition. Let's say we wanted to find the, 66th percentile. Okay, so that'd be C equals, there are 6 data points. We want to multiply by the percentile with 66 and divide by 100. So we go 6 times 66 divided by 100 equals 3.96. So we round up to the next whole number. So that's the 4th. So the 4th number, that's 88. That's the 4th number in this sequence. 88 is the 66th percentile. Now, it's a lot of different percentiles, but it is the 66th percentile. So, and that, even if this was the number 3.01, I would still round up to 4. We're not rounding to the nearest number, we're always rounding up to the next whole number. Okay, so that's percentiles. The next thing we want to do is we're going to look at quartiles and check for outliers.